Hey Celeste. So I've been requested to talk about the sun being really young, between 5 to 13 million years old. I have it as 5.8 to 13.1 million years old rather than 4.6 billion. A few reasons here. Stellar evolution is a continuum, not a star versus planet dichotomy. Young stars, planets are hot, bright, bloated, and active. I like that word, bloated. Old stars are small, cool, dim, and chemically differentiated. Um, in reverse logic here, if the sun were 4.6 billion years old, it should not be in its hot plasma state. It should have cooled into something like the Earth or even Mars. There's no way that the sun is that old. I mean, just look at Mars. Just look at rock formations on the Earth. These things are incredibly old, billions of years old. And then look at the sun. There's no way. The sun's still luminous and active. It's very, very early in its life. Number two, stellar magnetic activity indicates youth in stellar metamorphosis. Within the theory, if there's a strong flaring, that signals youth. If there are complex magnetic cycles, that signals youth. High solar wind flux, so materials coming out of it in huge amounts, that signals it is very young. Huge convective zones, that also signals that it's very young. And its huge axial angular momentum compared to other older stars. It carries a lot of that axial angular momentum from when it was born. Stars are born with incredible spin energy. So there's an aspect of stellar evolution, or stellar birth, I should say, that causes the material to spin extremely rapidly with a lot of energy. I don't know what that is yet, though. So strong magnetic activity equals young, which implies tens of millions of years versus billions. The strongest argument that I remember I found out, I was like, what the heck's going on here? Is the Kevin Helmholtz realization. Basically, the sun's output, its luminosity is 3.8 times 10 to the 26 watts. If you assume the sun is primarily powered by gravitational contraction, a shrinking gas or plasmatic body, the energy reservoir lasts on the order of 10 million years, not billions. So it only has enough energy in its current state to gravitationally collapse a max of 10 million years. So essentially, when it does cool and collapse, that material does cool down and it stops radiating, and all the energy starts cooling off essentially. So it can't radiate to the same output that it is now. So yeah, the sun in its current state can only last for 10 million, but its state changes as it undergoes metamorphosis, which is easy to understand, really. And it was historically the Kevin Helmholtz idea before the nuclear fusion guys down the hall started making a mess of the situation. In stellar metamorphosis, fusion is negligible. Surface lightning or plasma reactions are not the main energy source. It is as simple as that. Sure, there can be fusion on it, but it doesn't keep the sun hot. It's far too turbulent. It's far too complex. The idea that mathematicians allowed for fusion to power the sun is based on the idea of the assumption that Earth and the sun are about the same age, and Earth is billions of years old. Ipso facto, the sun has to be billions of years old, but the Earth hasn't always been around the sun. The sun is very, very, very young compared to the Earth. And the sun's age is roughly gravitational contraction time scale, 5 to 15 million years. It's pretty simple to understand. It's not hard. Anyways, for lack of billions of years evidence in the solar atmosphere, in mainstream astrophysics, extremely long solar age is established by radioactive dating in meteorites, solar modeling tied to nuclear fusion, and helioseismology calibrated to fusion models. So fusion, objects that aren't even related to the sun. Meteorites are objects or stellar pieces of stellar cores that have long since cooled off, condensed, collected, and then redisintegrated and broke up into outer space. So they're probably hundreds of trillions of years old. The fact that they allowed them to be billions of years old, and the fact that they said that meteorites are the same age as the sun, is kind of weird because the sun is mostly helium and hydrogen. Yet meteorites are mostly iron and nickel and rocky materials such as silicon and olive iron. The sun's composition, mostly helium and hydrogen, almost no heavy metals, are signatures of young stars because old stars, according to stellar metamorphosis, become metal-rich as they cool and condense. And that's exactly what the purpose of the idea is. The helium and hydrogen gets lost, and the heavier material stays left over and collects in the center. And the magnetic properties of some material allow it to sort differently, like iron and nickel, which is why it collects in the interior of the star as it cools and collapses in large amounts. The lack of heavy element differentiation in the sun's photosphere supports a young age because metals haven't had time to settle or form planetary crusts, and it's as simple as that. Thus, helium and hydrogen domination equals youth. And again, it makes complete sense when you look at it like that. Okay, so do another one, putting it all together. But anyways, I think that sort of wraps it up for now. And it definitely is going to hurt a lot of people's feelings, a lot of astronomers and astrophysicists' feelings, that they kept on teaching the sun is billions of years old, but mountain ranges are tens of millions of years older than the sun. Okay, the Earth's oceans at their oldest state are tens of millions of years older than the sun. Earth has been around for extreme periods of time, and to state that Earth and the sun are about the same age is sort of not really looking and observing. It's sort of going into math fantasy land and making claims that which don't really make any sense, especially when you look at all the other things that you can observe in light of an idea that can make sense of those observations. So I'm sure my listeners already are fully aware of that. Anyways, later, y'all.